Welcome to Stoneglass Industries and the Prosthetic Design Center software, otherwise known as PDC, a unique and innovative solution that comprehensively supports both clinical education and patient care in the realm of CAD/CAM digital technology. To summarize what makes this software distinctly different from other systems is its versatility. There are three key arenas where this is demonstrated. First, the scope of the type of restorations and reconstructions that can be designed with PDC includes tissue, tooth, and implant-borne prostheses to accommodate partial or full arch situations. Secondly, the array of prostheses that can be generated includes custom trays, bite blocks, verification jigs, radiographic and surgical guides, and more. This is all done within the same software where you have full control to independently custom design the type of prosthesis you want as a clinician for your patient. Finally, it can be used in the academic and clinical realms, both in universities and in private practices. The flexibility of the software affords a seamless transition from preclinical to clinical realms. PDC can be used in the classroom where a case to work up can be deployed to an entire class at once, and it can be used on the clinic floor with patients. The software was not built for engineers and technicians. It was designed with the clinician in mind and with occlusion as its centerpiece. For instance, in the area of complete and partial dentures, if desired, occlusal rims can be designed and printed. Adjusted resin rims or traditional wax rims can be scanned into the software so that they may act as a guide or overlay for the placement of virtual teeth. The tooth libraries used are genuine, high-quality Heraeus culture teeth. If the patient were to fracture a tooth in the future, the lab can send the exact adjusted prosthetic tooth that will precisely inset into the milled base. Custom trays can also be designed with precision relief and tissue stops. Anterior tooth setting is performed in the same way on the virtual articulator, where catalogs highlight the teeth that would fit within the region you delineate, and the posterior teeth are set according to where you want the central fosses of the mandibular teeth. You can independently move the teeth, mirror position changes to the other side, and otherwise customize the setup at any time. If you do not like the teeth you selected, you can go right back into the catalog and pick out a different size, even if it is outside the suggestions of your original boundaries. Students can more easily treatment plan patients while actively creating prostheses according to soft and hard tissue present, implant angulations, etc. They can also perform model extractions and surgery and examine clearances and better appreciate functional space from any angle. Foundational rules on tooth setting are supported, including setting posterior mandibular teeth on the center of the alveolar ridge and vertical and horizontal overlap visualization in the anterior area so this user can optimize their tooth setup. Designs can be printed as try-ins and delivered to articulated models, or to the typodont, or to a clinical patient. Protrusive and lateral excursive simulations to view occlusal schemes and address any interferences are available. Articulator settings can be programmed as well, including condylar guidance, Fisher angle, Bennett angle, immediate side shift, and more, especially relevant in postgraduate programs. What you see here is an occlusal contacts mode, basically pressure mapping within the program. Digital occlusal analysis allows easy visualization of heavy destructive contacts or guidance. Here displayed is an example of how occlusal points are coincident, and the articulator can be used as the final verification. This is especially useful when doing partial and full arch arrangements opposing natural dentition, which may not always support an ideal occlusal plane. There is a virtual grinding feature in PDC which can be selected, which adjusts the occlusal surfaces of the teeth to accommodate opposing uneven contacts. Intraoral scans are also readily accepted by PDC. You can clean and solidify models for easier acceptance by printing software, as well as still mount on the virtual articulator. No need for mounting stone. There's even model building software within PDC that allows for you to reuse spacer discs and stack them to affix a hollow model. This saves resin, gypsum, and time. Even if you have intraoral scans, you can still mount them on an articulator if desired. Once your design is finalized and accepted by you and your patient, it can then be sent to Stoneglass for final milling and manufacture. It can be simple to more complicated frameworks to address the most challenging cases. Often models are not necessary to be sent so that the lab receives your case electronically in seconds. By now, you have seen that the software accepts both scans from tabletop scanners as well as optical wands. The virtual articulator takes over and your prosthesis can be designed. Teeth position is initially established, followed by gingival sculpting. The design is now ready to be converted into an STL or brought into other modules within PDC. This is the basic workflow. For instance, you can convert your design within the software into a radiographic or surgical template. If you have an in-house printer, you're able to print any of these items at any time. Receptacles or pockets are incorporated to house fiducial markers. No secondary scan is needed when co-diagnostics is used. The patient merely wears it at the time of the scan. This will allow not only your templates to be overlaid with your DICOM, but you can also take any scans and designs archived in PDC and bring those in as well. Soft tissue overlays can be imported from PDC, for instance. This, of course, helps with tooth and tissue supported guides and allows for proper placement of implant guide sleeves. Here you also see how a VDO guide was also generated by PDC and worn during the CBCT so that it could provide precision vertical support and facilitate easier segmentation of the target arch in the surgical planning software. It can also be useful for immediate load cases. This is a closer depiction of a cross-sectional application of the soft tissue imported from PDC into co-diagnostics. Any design or scan in PDC can be brought in to assist with the placement of sleeves, bone fixation screws, etc. For instance, you may have performed model alveoloplasty or performed virtual extractions, and that new tissue topography can easily be brought into co-diagnostics. Here you see an ideal radiographic surgical guide that was designed to also give an indication as to where ideally implants could be placed, and it makes it easier to site those areas and vet out those locations quicker when united with the DICOM. You see the cross-sectional depiction of the implant angulation traversing through the aperture here. This is the surgical template generated by co-diagnostics and how it allows the soft tissue previously imported to be incorporated into the foundation. An immediate load prosthesis was provided to this individual, and the coincidence of the plan and the clinical work is apparent. Once you have a verified soft tissue implant model, you can attach scan bodies and scan your new model back into the case in PDC. You can create a new design or bring in a previous design. You can then create a try-in prosthesis and verify implant placement, aesthetics, centric occlusion, and vertical dimension. It can be a simple solid resin print that screws directly down to the implant platforms, or for greater stability and radiographic confirmation, you can place pre-made supportive titanium posts that can be luted to a print. These posts can also serve as a foundation for a provisional you could potentially generate for minimal to no cost after keying the prototype on the model and using your acrylic of choice. There is also a module within PDC that allows you to select the appropriate angulated abutment that supports your prosthesis design aesthetically and biomechanically. A 17-degree and a 25-degree option is displayed, and this demonstrates how it helps in the process of ordering components. This area is useful to teach in pre- and postdoc curriculums as well. Try-ins can be verified back on the articulator, and once approved, the design can be electronically sent, and Stoneglass technicians can begin the process of milling titanium substructures as well as milling the teeth, which can be made out of zirconia, lithium disilicate, or wear-resistant Heraeus prosthetic teeth for a more economically driven, lower-cost alternative. As a clinician, how many times have you waxed up a case only to see it altered by a lab to accommodate a metal substructure? With PDC, your virtual case can be sent to the lab where the substructure will be created to fit within your design. The advanced milling capabilities available allows for slender and supportive frameworks. Stoneglass has recognized that a critical consideration is that a prosthesis should be designed to be serviceable and maintainable. For fixed cases, unit-built elements with lingual metal buttresses allows forces to be spread throughout the prosthesis. Teeth can be replaced at any time, and sluiceways for cleansability are additionally incorporated because hygiene and soft tissue maintenance is not an option, it's a necessity. When thinking about the broader picture, the software is designed to archive and manage the multiple stages or levels of patient care. It is important to note that with PDC, the same tooth design can be used even when the underlying models change. For instance, if you retake an impression or correct a mounting, it just requires that you scan the remounted model and have it replace the previous model. The spatial tooth arrangement will not change unless you want it to. Previous scans and other work are all archived and readily accessible as a reference. Above on the left, you see a partially dentate mandible with a virtual setup. And then in the middle, tooth model extractions were done virtually with the identical placement of the teeth design still present. And in the last example, the vertical dimension has been changed within the software. Nevertheless, the spatial placement of the teeth design remains the same. No resetting of teeth is necessary. A virtual setup can carry through from start to finish, saving a lot of time and butane. In summary, what does this software offer? It is both a clinical and an educational tool that provides the ability to actively participate in as much of the prosthetic design process as desired. It can be part of a foundational curriculum to build basic skills in the setting of teeth and festooning for partial and complete fixed and removable prostheses, as well as treatment planning. Art and science not only are combined, but they're optimized. The workflow follows the logical analog progression and can be verified in the same way. The versatility of the software allows for intraoral scans and tabletop scanners to be used to input patient data to be integrated into the virtual articulator and for the user to be able to print any design they develop. This independence serves to reduce costly redos and time while determining the best prosthesis design for the patient. The data can be electronically sent from manufacturer, where both biomechanics and aesthetics can be united within the design using high quality materials and manufacturing practices led by expert technicians and engineers. And so, at its core, Stoneglass is a manufacturing and research facility that specializes in dental and medical laboratory work with an enthusiasm to partner with clinicians, universities, and teaching facilities to continue the tradition of providing high quality, innovative approaches to rehabilitating patients and participating in the educational process. The software suite is a platform that has received input from prosthodontists, surgeons, and universities and medical centers around the world. Whether you are in private practice or contributing to an academic curriculum, or both, we would welcome you as a part of our family. We endeavor to provide the best methods and materials for patients and the doctors who serve them. If you have any questions about the Prosthetic Design Center software or need help determining system needs that match your facility from software to hardware, we would be happy to discuss. Links to videos are available to see actual in program demonstrations. Thank you for this opportunity to share our innovation.